Good morning, everyone. Myself, Dhanalakshmi. I am working as an assistant professor at National Engineering College in Electrical Department. Now we are going to discuss the topic of restriking voltage and its derivation. So the restriking voltage, the transient voltage that appears across the contacts of the circuit breaker immediately after extinction. At current zero, the restriking voltage will appear. This is the restriking voltage. Its physical meaning is the arc extinguishes at current zero. If the current zero, the arc will extinguish, but the system still has stored energy in the form of inductance and capacitance. The inductance it store magnetic energy and capacitance store electrostatic energy. So this energy exchange causes a high frequency oscillatory voltage across the breaker contact. It's called a restriking voltage. This is the equivalent circuit of the system is approximated as system voltage and inductance and capacitance. This is the contact of the breaker. This is the equivalent circuit, series inductance and parallel capacitance across the contact of the circuit breaker. This forms AC oscillatory circuit under initial condition. Current I is equal to 0. Capacitor V is equal to capacitor across voltage VC is equal to 0, and energy stored in inductor E is equal to half Ni square. Then the circuit breaker contacts are open and the arc is extinguished, and the current I is diverted through capacitance C, resulting is transient condition. The inductance and the capacitance form a series oscillatory circuit, and the natural frequency F1 is equal to 1 by 2 pi root of LC. This is the natural frequency of oscillation, and natural angular frequency omega n is equal to 2 pi Fn. Now Fn is equal to 1 by 2 pi root LC. This one and this one cancel. Now the angular frequency is equal to 1 by root of L by C. The voltage across the capacitance the voltage across the capacitance, which is the voltage across the contact of the circuit breaker, can be calculated in terms of inductance, capacitance, and natural frequency and system voltage. The mathematical expression for the transient condition L into dA by dt plus 1 by C integral of I into dt is equal to Vm cos omega t. The transient immediately after the instant of arc extinction, the voltage across the capacitance Vc is the restriking voltage oscillates at the natural frequency. During this short period, the change in the power frequency term is very high, very little, and it's negligible. So omega t is equal to 0. Now substitute cos omega t is equal to cos 0. Then we got a L into dA by dt plus 1 by c integral of I into dt is equal to 0. Uh, now the I is equal to the according to Ampere's law, I is equal to dq by dt. C is equal to q by v. Now q is equal to c v. But voltage is the capacitor across voltage. Then CVC. Now we substitute q instead of q CVC. Then I is equal to TCVC by dt. Then di by dt is equal to d squared CVC by dt squared. Now the c is the constant. Then uh, then L into we substitute d instead of da by dt, c into d squared vc by dt squared. Here 1 by c integral of I into dt is equal to vc equal to vf. Now taking Laplace transform on both sides. So LC S squared dc of S plus dc of S is equal to Vm by S. So here dc of S is common. So take Vc of S common. So we got LC S squared plus 1 is equal to Vm by S. Now we finalized. Now we calculate Vc of S. Then now we calculate capacitor across voltage is called restriking voltage. Then Vc of S equal to 1 by S Vm by S into LC S squared plus 1. Then omega n is equal to 1 by then omega n is equal to 1 by root of LC 1 by root of LC. Then 1 by L is equal to omega n squared. Now substitute 1 by LC is equal to, so then Vm omega n squared by S into S squared plus we taken LC is common. Then here 1 by LC. So 1 by LC is equal to omega n squared. We take omega n is common. Then Vm omega n is Vm omega n is taken as common. Then omega n by S squared plus omega n squared as that. Then omega n by S squared plus omega n squared is the sin t. Taking this is the taking inverse Laplace transform. Then we got Vc of t is equal to omega n Vm by here integral 0 to t sin omega n t. Now omega n Vm we replace integration term. So we got cos omega n t by omega n 0 to t. Finally we got Vc of t is equal to Vm we substitute instead of t is equal to t, instead of omega n t is equal to t, omega n t is equal to 0. Finally, we got 1 minus cos omega n t. This expression This expression is called a restriking voltage. Important characteristics: the auxiliary voltage is this is the angular frequency voltage. The auxiliary voltage is the cosine waveform and high frequency. So at maximum restriking value at t is equal to 12 by omega, then omega is equal to 1 by root MC, then pi omega is equal to pi into root MC. Hence the maximum restriking voltage obtained to Vm. This is the maximum value of restriking voltage is the 2 Vm, and rate of rise of restriking voltage is the TV by dt. Then we differentiate d by dt, and v is the Vm 1 minus of omega nt. Finally, we will differentiate. Finally, we got Vm omega n sin 1 minus cos omega nt is the sin omega nt at maximum value omega n t is equal to pi by 2, then t is equal to pi by 2 omega, then now the maximum value of RRB is the Vm omega n. So this is the maximum value of RRB. Now we now we look for one problem. Now we look for